Luis Carlos Cárdenas and Rafael Montes, and we're going to present the problem number 2 of Math 5. It's the first partial project. The problem says that Yula had a very tough day and went to the roof of her 300-meter tall building to have some peaceful time. Drinking bottles of water on the top of the building was the best at the moment. After finishing the water, a strong wind started and thrown upward the bottle with an estimated velocity of 100 meters per second.
We need to find our position equation. We got this information that the problem established. Then we have the formula that is y plus the initial velocity plus 1/2 of heavy and time at square. Then we substitute with the values and we obtain this equation.
Then the problem asks us to, in the part B, to get the equation of the velocity using the derivative definition with limits. So this is the formula of the derivative definition of limits. So when we have all our values, we just substitute. So we put 300 plus 100 in parentheses t plus h minus 4.905 in parentheses t plus h to the square minus 300 minus 300t plus 4.905 t squared. So in this part, we go to this part and we take out the 300 with the 300 and that's it. So we go to the next part. So we have 100t, that is this one, t because it's 100 multiplying t and h, so 100t and 100h, minus 4.905 t squared because of this part, because it's to the square, minus 9.81 ht because it's multiplying both, minus 4.905 h squared minus 100t and plus 4.905 t squared. So in this part we have 100t and minus 100t, so those ones go out, and minus 4.905 t squared with plus the same thing, so they also go apart. And in the next part we only put the values that we have, so 100h minus 9.81 ht minus 4.905 h squared, that is this one. So all of these over h. So in this part we need to get out the h, because in all these parts we have h, so we take out the h. So the h is already out and we have all these. So without the h is 100 minus 9.81t because we have the h, and minus 4.905 h over h. So we eliminate the h with the h in this part, so we can go to this part, and the only thing that we have are the values that we had in this part. And having this, we can get our by, that is equal to 100 minus 9.81t minutes over seconds.
Then the next step is to get the acceleration equation of the plastic bottle. Then we have our values here, 100 minus 9.81 times t plus h minus 100 plus 9.81t over h. Then we solve. This goes with this because it's the same but with different sign, and then we only have this that is in this equation. We get out the negative sign so we can simplify the equation, and at the end we get that a is equal to minus 9.1 meters over second squared. We know that the acceleration is a constant value because there is no other force or acceleration to modify this value, which is the gravity.
In the part D, the problem asks us to calculate the height of the bottle after 2 seconds. So the only thing that we have to do is substitute time by 2 seconds. So we have also this, that is time. So we only substitute 300 plus 100 times 2 minus 4.905 times 2 to the square. So that is equal to 300 plus 200 minus 19.762. So we only multiply by 2, and here we multiply by 2 to the square. And we get this. When we get this, the result of this equation is 480.38
to calculate after what period of time the ball hits the ground. Then we substitute values, we obtain this, and we need to isolate t. So it is 100 with the square root of 10,000 minus 4 times 4.905 times minus 300 over 2 times 4.905. The result of this equation is this. That is t equals to 23.042 seconds. This means that after this time, the ball hits the ground.